Good day, math learners! In this video, we will talk about the concept on permutation. What is permutation? Permutation refers to an arrangement of objects in a definitive order. Changing the order of the objects being arranged creates a new permutation. For instance, the sixth permutation of the three letters F, B, and O taken two at a time are the following. We have FB, FO, BO, BF, OF, and OB. The six permutations of these three letters taken three at a time are FBO, FOB, BFO, BOF, OFB, and OBF. The permutation of n things or objects taken r at a time can be denoted in different ways. In this learning packet, we will adopt the notation P, open and close parenthesis n, r. This can be read as the permutation of n things or objects taken r at a time. In the first illustration, there are three things or letters F, B, and O taken two at a time. So therefore, we have this permutation notation. So the permutation of three letters taken two at a time is equal to 6. In the second illustration, there are three things or letters taken three at a time. So we can denote it as the permutation of three letters taken three at a time is equal to 6. Finding the number of permutations of n different objects taken r at a time is the same as finding the number of ways that can fill r places when there are n different things to choose from. Let us consider the first example. How many different ways can 7 students be seated for a selfie if only 4 seats are available? There are 7 objects to choose from, therefore, n here is equal to 7. There are 4 places to be filled, therefore r is equal to 4. So our notation would be the permutation of 7 objects taken 4 at a time. Since there are 7 objects to choose from, by fundamental principle of counting or FPC, the first seat can be filled in 7 ways. The occupant of the second seat can be chosen from the 6 remaining students. Thus, the second seat can be filled in 6 ways. After the first 2 seats are filled, the third and the fourth seats can be filled using the same reasoning in 5 and 4 ways, respectively. So we can compute it this way. So we have 7 times 6 times 5 times 4 is equal to 840 ways. So the dot here represents multiplication. Therefore, there are 840 different ways the 7 students can be seated in 4 seats. That is, the permutation of 7 students taken 4 at a time is equal to 840 ways. Example number 2. How many permutations can be made for 5 different books on a shelf that can accommodate exactly these 5 books? So first we have to identify our n and r. N is equal to 5 since we are given 5 different books, and r is equal to 5 since we have to accommodate all books in the bookshelf. So we have the notation, the permutation of 5 books taken 5 at a time. So to compute using fundamental principle of counting, we can make use of 5 times 4 times 3 times 2 times 1. That gives us 120 ways. Thus, the permutation of 5 books taken 5 at a time is equal to 120. So to simplify the process that we had used on the previous slide, so we denote that one as the factorial notation. So the product 5 times 4 times 3 times 2 times 1 can be written in abbreviated form 5 with the exclamation point, or we can read that one as 5 factorial. So 5 factorial would mean 5 times 4 times 3 times 2 times 1, and that is equal to 120. Another example would be 7 factorial. So we begin with 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is equal to 5040. Another example, 4 factorial. So we will begin with 4 times 3 times 2 times 1, therefore that is equal to 24. Then 6 factorial, that is equal to 6 times 5 times 4 times 3 times 2 times 1, and that is equal to 720. So n factorial, for every positive integer n, so that is equal to n times quantity n minus 1 times quantity n minus 2 until you have 3 times 2 times 1. Evaluate the following. So first example, we have 9 factorial minus 6 factorial. So first we have to rewrite 9 factorial. So we have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 minus 6 factorial. So we have to rewrite 6 factorial as 6 times 5 times 4 times 3 times 2 times 1. Then after which, get the product of each factorial. So we have 362,880 minus 720. Then subtract the two numbers, it gives us the value of 362,160. Another example would be 3 factorial plus 2 factorial. Still, you have to rewrite it. So we have 3 times 2 times 1 plus 2 times 1. And get the product of each factorial. So we have 6 plus 2. So thus, our answer is equal to 8. Another example would be 7 factorial divided by the product of 7 factorial and 3 factorial. So in this case, so since we have 7 factorial for both numerator and denominator, so we can immediately cancel both 7 factorial. So we are left with 1 over 3 factorial, and we have to rewrite 3 factorial with 3 times 2 times 1. Then simplify. So our answer is equal to 1 over 6. Then another example, we have 7 factorial divided by 7 factorial minus 3 factorial. So we have to rewrite again 7 factorial as 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by, then rewrite the 7 factorial minus 3 factorial. We have 3 times 2 times 1, then get the product of each factorial and simplify. Therefore our final answer would be 840 over 839. So we can also have the formula in finding the permutation. So the number of permutations of n objects taken R at a time is the permutation of n taken R at a time is equal to n factorial divided by quantity n minus r factorial. So for example number 4, we have to evaluate the following. So the permutation of 6 things or objects taken are taken 4 at a time. So we have to identify our n and r. N is equal to 6 and r is equal to 4. Then substitute this one to our given formula on permutation. So we have 6 factorial over quantity 6 minus 4 factorial. Then we have 6 factorial divided by 2 factorial. Then rewrite 6 factorial. So as you have noticed, we did not stop at 1. Since in our denominator, so we have already 2 factorial, so we will just stop until 2 factorial or whatever number is in your denominator. And since you already have the same 2 factorial in both numerator and denominator, so you can immediately cancel. Then we are left with 6 times 5 times 4 times 3. So the permutation of 6 things taken 4 at a time is equal to 360 ways. Another example would be the permutation of 13 objects or things taken 3 at a time, so n is equal to 13 and r is equal to 3. Simply substitute from the given formula. So we have 13 factorial over quantity 13 minus 3 factorial is equal to 13 factorial over 10 factorial. So in this case, we will stop until 10 factorial since our denominator here is already equal to 10 factorial. So we have to cancel 10 factorial. So you are left with 13 times 12 times 11. So our answer is equal to 1,716 ways. Example number 5. 8 students are lined up to be seated. How many ways can 4 of them be seated in a row of 4 chairs? Then the second question would be, how many ways can all of them be seated in a row of 8 chairs? So for letter A, so we can denote this one as the permutation of 8 students taken 4 at a time. So our n here is equal to 8 and r is equal to 4. Then substitute our given formula. So we have 8 factorial over 8 minus 4 factorial is equal to 8 factorial over 4 factorial. In this case, we will end with 4 factorial since our denominator is also 4 factorial. So cancel that one. So you are left with 8 times 7 times 6 times 5. So in letter A, our answer is 1,680 ways. For letter B, since we are talking about all of them, therefore our n here is 8 and our r is also 8. So the permutation of 8 students taken 8 at a time, so that is equal to 8 factorial over the quantity of 8 minus 8 factorial is equal to 8 factorial over 0 factorial. And that is equal to 8 factorial since the definition of 0 factorial is simply equal to 1. So for 8 factorial, to simplify, that gives us 40,320 ways. Example number 6. How many ways can 4 officers in grade 10 Newton class be elected among 45 students? So first we have to identify our n and r. So our n here is 45. So that is the total population. Then r is equal to 4. Then the permutation would be the permutation of 45 students taken 4 at a time. Then substitute our formula. So we have 45 factorial divided by quantity of 45 minus 4 factorial. So that is equal to 45 factorial divided by 41 factorial. That is equal to 45 times 44 times 43 times 42 times 41 factorial. We stop until 41 factorial since our denominator is equal to 41 factorial. After which, cancel. Then multiply what is left. So therefore, our answer is equal to 3,575,880 ways. How many 4-letter words can be formed from the letters in these words? So the first word is gold and the second word is silver. So let us answer first. Letter A. Gold has 4 distinct letters, so therefore our n here is equal to 4. And 4-letter words, so r is equal to 4, are to be formed. So using our formula, so we have 4 factorial divided by quantity 4 minus 4 factorial is equal to 4 factorial over 0 factorial. Again, by definition, 0 factorial is simply equal to 1. Thus, 4 factorial is equal to 24 ways. For letter B, silver has 6 distinct letters. Therefore, our n is equal to 6. And since we have to form 4 letters again, therefore our r would still be 4. Then, so we have connotation, permutation of 6 letters taken 4 at a time is equal to 6 factorial divided by quantity 6 minus 4 factorial is equal to 6 factorial divided by 2 factorial is equal to 6 times 5 times 4 times 3 times 2 factorial. So we end at 2 factorial since our denominator is also 2 factorial. Then cancel. So we have 6 times 5 times 4 times 3. Therefore, the answer is 360 ways. Example number 8. How many different ways can the letters of the word Quezon be arranged? The letters of the word Quezon are distinct from one another. Thus, these letters can be arranged in. So our n here is equal to 6 since we have a total of 6 letters from the word Quezon. Then since we have to use or to form all letters, so we have our r is also 6. So our permutation of 6 letters taken 6 at a time is equal to 6 factorial, which is equal to 720 ways. Permutation with repetition. When some objects are not distinct, are not different, the number of permutations can be determined using the following rule. So this rule is called permutation of n things not all different. The number of permutations of n objects of which p are alike, q are alike, r are alike, and so on is equal to n factorial divided by the product of p factorial, q factorial, r factorial, so on and so forth. Example number 9. How many different ways can the letters of the following words be arranged? Letter A, Manila. B, Pangasinan. C, Tagaytay. Let us answer first letter A. In the 6th letter word Manila, since Manila has a total of 6 letters, so that will be our n. So we have 2 letter A's. So that will be our P, and that is equal to 2 since A here is repeated twice. Thus, these letters can be arranged in 6 factorial over 2 factorial. Then simplify. So cancel out 2 factorial. Then the correct answer is 360 ways. Letter B. For Pangasinan, so Pangasinan has a total of 10 letters, so therefore our n here is equal to 10. And at the same time, we have letter A, which is repeated thrice, therefore p here is equal to 3. And also n is also repeated thrice, so n here is also equal to 3. So we will be using n is equal to 10. P equals 3 for letter A, and Q equals 3 for letter N. Then, we have 10 factorial divided by the product of 3 factorial and 3 factorial. Then, rewrite 10 factorial. So we stop at 3 factorial since our denominator has 3 factorial. So we can immediately cancel. Then for the other 3 factorial, just rewrite it as 3 times 2 times 1. Then simplify. So we have the correct answer is 100,800 ways. Letter C, Tagaytay. Tagaytay has a total of 8 letters, therefore that will be our N. So we have T here, which is repeated twice, so that will be our P. P here is equal to 2, so that will be for letter T. Then A here is also repeated thrice, so A here, that will be our Q, which is equal to 3. And Y is also repeated twice, so this will be our R, which is equal to 2. So these letters can be arranged in 8 factorial divided by the product of 2 factorial, 3 factorial, and 2 factorial. Then rewrite 8 factorial. So in this case, we end at 3 factorial since the bigger number here in our denominator is equal to 3 factorial. So cancel out 3 factorial. Then for the remaining 2 factorial, just rewrite it as 2 times 1. Then after which simplify, so we have the correct answer is equal to 1,680 ways. Another example would be, in how many ways can 3 rhinestones, 5 crystals, and 2 precious metals be arranged into a bracelet? In this case, there are 10 objects. So where did we get 10 objects? So we just added 3 rhinestones, 5 crystals, and 2 metals. So 3 plus 5 is 8 plus 2, 10. Therefore, N here is equal to 10 to be arranged. 3 of these were rhinestones, so that will be our P. 5 of these were crystals, so that will be our Q, which is equal to 5. And 2 of these were 2 precious metals, and that will be our R, which is equal to 2. This permutation with repetition because we need an ordered arrangement, but some beads were repeated. So we can use this formula. We have 10 factorial divided by the product of 3 factorial, 5 factorial, and 2 factorial. Then rewrite 10 factorial as 10 times 9 times 8 times 7 times 6 times 5 factorial. So we end with 5 factorial since in our denominator, the highest number we have is 5 factorial. So cancel out 5 factorial. Then for 3 factorial, you have to rewrite it as 3 times 2 times 1. Then for 2 factorial, we write it as 2 times 1. Then simplify. Therefore, we have a total of 2,520 different bracelets can be made from these beads. We also have another permutation, which is what we call as the circular permutation. The number of permutations of n distinct objects arranged in a circle is the quantity of n-1 factorial. Example number 11. How many ways can 9 people sit around a circular table? So our n here is equal to 9. Then simply substitute from our given formula the quantity of n-1 factorial. So we have the quantity of 9 minus 1 factorial is equal to 8 factorial. Then simplify. So we have a total of 40,320 ways. Another example, how many ways can 5 keys be arranged in a key ring? So our n here is equal to 5. Then substitute from our formula. So the quantity of n-1 factorial is equal to quantity 5 minus 1 factorial is equal to 4 factorial. Then our answer is equal to 24 ways. And this ends our lesson on permutation. Thank you.